5.5, average value of a function. So let y1, y2, y3, and so on, yn, let these be finite number of numbers. Then we find the average value, y average, is that we add them, y1 plus y2 plus yn divided by n, and that's how we find the average. But the key here is we have finite number of numbers. So with a function that has infinitely many values, how do we do that? So this is our question. But how do we compute the average value of a function, for example, of temperature? During the day, this is an example of a function that's continuous if infinitely many temperature readings are possible. Infinitely many temperature readings or values are possible. So imagine the temperature as a function in a 24-hour period. So this is T, and this is the time and the temperature from 0 to 24 hours. And the graph looks something like this. All right, so we always can find average value or average temperature for a day, and it may be, let's use green, maybe somewhere here. So this is the average value, T average, the green line. So the question is, how do we do that? How do we compute that if we have infinitely many values? So let's try to compute the average value of a function. Let's compute the average value of a function y equals f of x, and x is from a to b, in our case from 0 to 24 hours. So we take the interval from a to b and divide it, we divide it in n equal parts. Or subintervals. Okay, so delta x, each subinterval is the length b minus a divided by n, just like before. We choose points, let's call them x1 star, x2 star, so on, xn star. Then we calculate the f values of those points, fx1 star, fx2 star, and so on, fxn star. Then we add them up, f of x1 star plus f of x2 star plus the last one. And we divide by n, because that's how we compute the average value. Now, since delta x is b minus a over n, we can solve for n and say n is b minus a over delta x. So now, our expression, the same expression, you're adding them all up, divided by n, that should equal to, let's substitute n with this expression, and we're going to have here f of x1 star plus f of xn star. And on the bottom, instead of n, b minus a over delta x. So we're continuing this expression now. So that's equal to 1 over b minus a, and inside we have f of x1 star plus f of xn star and times delta x. So this delta x that was on the bottom here, if you multiply by delta x, it's going to appear right here. So continuing, now I'm going to multiply everything inside the parentheses by the delta x. So I have fx1 star delta x plus fxn star delta x. Now this is sum, so we can use the sigma, they're n terms, and inside what we're adding fxi star delta x. Now we're going to take the limits. We're going to take the limit of this expression and let n goes to infinity. And this is familiar. This is a Riemann sum. We're taking the limit of a Riemann sum. The only difference is we have this constant 1 over b minus a, which we can pull on the front. And then what's left is a definite integral from a to b f of x dx. We know the limit of this Riemann sum is a definite integral. So here's a definition on average value of a function. Average value of f, function f, on the interval from a to b is f average 1 over b minus a integral from a to b f of x dx. So that's all there is. Pretty simple definition. It's a definite integral which we divide by b minus a. For example about calculating average value. Find the average value of f of x Find the average value of f of x if f of x is equal to 1 plus x squared, and you need to have an interval. So on the interval from -1 to 2. Now, the interval tells you what a is and what b is. So the average value will be 1 over, let's write the formula, b minus a integral a to b f of x dx, which is equal to 1 over, well, what's b minus a? 2 minus -1, so 3. Integral -1 to 2, 1 plus x squared dx, which is easy to calculate. You should get 2. So the average value of the function is some number that we calculate with that formula. Now, back to our example with the temperature. We have another question. So if T at some time T is the temperature, at time T, we might wonder if there is a specific time. We might wonder if there is a specific time when the temperature is the same as the average temperature. Okay, so back to our picture, or we can draw another picture. This is the temperature function with time t, and in a 24-hour period, if the average temperature is this red line, we wonder if there may be a time And there is right here at that point, the average temperature, it's exactly equal to some other temperature in between the 24-hour period. So in general, there is a number C, we'll call it C, where f of C is equal to the average value, and they could be more than one. So the following theorem says that this is always true for continuous functions. So that theorem, it's called the mean value theorem for integrals. The mean value theorem for integrals. And it goes like this. If f is continuous on some interval ab, then there exists a number c in the interval from a to b such that fc is equal to the average value, which we know the formula 1 over b minus a, integral from a to b, f of x dx. That is, we can rewrite this formula as integral a to b f of x dx equals to f of c times b minus a. Geometrically speaking, we can see this picture back with our function, could be any function. This is our function f of x from a to b, and our average value is somewhere here. So this is the average value, f average. So this theorem basically says that the area of the rectangle, okay, so this rectangle, I'm talking about the red rectangle. So this area, which is the right side over here. So this f of c times b minus a, it's the area of the red rectangle, right? The height is f of c, because that's where that point C is. That is the area of the rectangle. And on the left side, we have definite integral, and we know what that is. That's area under the curve. So this is area under the curve. So we say these two are equal, which makes sense, because the area under the curve is a little bit higher here, but a little bit underneath the red line here. All right, example, f of x is equal to 1 plus x squared, the same function. It's continuous everywhere, but it's continuous from -1 to 2. And by the mean value theorem for integrals, it says there exists some number c in the interval from -1 to 2, such that integral from -1 to 2, 1 plus x squared dx is f of c times b minus a, so that'll be 2 minus -1. Okay, so we already calculated this integral. We know that the average value is 2, right? So f of c is equal to f average, which is equal to 2. And now the question is to find c. 1 plus c squared is equal to 2. So c squared is equal to 1, and c is plus minus 1. So there are two such numbers that are equal to the average, which numbers you get the average value. So we can demonstrate this with a function because it's easy to graph. It's a parabola, 1 plus x squared, so it looks like this. And our interval is from -1 to 2. right? From -1 to 2. So the average value of the function turns out to be 2. And it makes sense. That's kind of the average height. If the function is, it starts here, what is that point? This point is -1, 2, so it starts at 2, goes lower down to 1, and goes up to 5. So this point here is 2, 5. So it makes sense, the average value to be 2. And that concludes this lecture.